Well, greetings, mathletes, and welcome back. Today, what we're going to be talking about is slope and how it relates to lines. I've always thought slope was kind of a fun little thing to play around with. Plus, I've always thought that Slope Dog would be a good rapper name. I think probably X Cube would be good as well, and maybe we could have a trio of rappers. We have Math Daddy, X Cube, and Slope Dog, and yeah, maybe they can be part of the Skew Line crew. Yeah, and reminding us lots of explicit functions, reminding us that function starts with FU. Anyways, without any further ado, yeah, it's probably best I never became a rapper or anything. Let's go ahead and actually talk about slope. Okay, so slope is a measure of steepness. If I have, oh, that's not on brushes. Let's try that again. If I have a straight line, let's try this again. Oh, Lord. Okay. Well, we're just going to pretend. Okay. So if I have a particular line here, and this is completely random. What I'm talking about when I'm talking about the slope is how steep something is. So, for example, if I draw a second line here, ooh, not quite as good of a line, but you can see that it is not as steep as the first line, and so it would have a slope that's closer to zero. And this is how you want to think about slopes. The steeper the line is, the closer to, the farther away from zero the slope is. So the flatter the line, the closer to zero. Something that looks like this would have a greater slope than this particular line over here, right? And you keep getting greater and greater as you get steeper and steeper. If you go the other direction, ooh, I'm just going to have to erase all of this. I keep doing that. Try this again. If you go the other direction, right? If you're putting slopes downwards like this, they are still getting farther from zero, but they're doing it in the negative direction. So slopes that go down to the right, like this, as I move to the right, the value drops down. Those are negative slopes. And if I move to the right and I move up, right, that gives me something that looks like this, and that's a positive slope. And so the way we're going to end up measuring slopes is looking at the difference. We're going to find 2 points from a line. And what we're going to do, if we want to measure this, we want to see how much y changes when I change x by a set amount. Now, this is a new symbol probably for a lot of you, this little triangle here. In math, in physical sciences, and in quite a few places, this is the Greek letter delta. And so this is delta x, right? If I put an x after this would be delta x. What it means is a change in x. Oops, that's the wrong symbol. There. Yeah, it means a change in x. And so when I put delta y, this is a change in y. Now, if you want to know how much something changes, what you actually end up doing is subtracting. So if I'm just going to give these points labels. So it's x1, y1, and x2, y2. Notice too, and I just want to point this out, this has entirely to do with notation and with how you say things. When I say things like x2, what it means is to put a subscript of 2 on there. That subscript, the only thing that is doing is distinguishing different x values. Since I have several different x values, I can't use x for all of them if I can't tell the x's apart, because it would cause confusion. Over here, x is 3. Over here, x is 5. It messes things up. So to tell the variables apart, we give them a little subscript. What I hear a lot and this is the wrong way to say this, is I see this quite often and hear people say x2, and that would be x squared or x to the second. And so the way you say it is very important. This would be said x2. This would be said x squared or x to the second, right? So you want to make sure you're speaking correctly when you say these things as well. Okay. So let me get that off of there, and we'll go back here. Now, looking at these things, right? Looking at this little triangle here, if I want to know how much y changes, I know y starts at whatever this first value is, y1, and it moves all the way up to y2, right? And so there's an increase here. I even have an arrow showing the increase. What I really want to know is how long that arrow is, right? So my change in y, when I want to find it, is y2 minus y1. If we take the two numbers and subtract them, it shows how much distance is between them. And the same thing with the x, right? I started with an x value over here, and I've moved to the right, so I have an x value over here. So if I want to know how long that little arrow is, it's x2 minus x1. Okay, so let me get this thing off of here so we can try to write a little bit. There we are. Now, the symbol that's used for slope is m. I've heard a lot of different stories about why m was chosen. Probably the most popular one was that they used it for mountain. There was a word for the slope of a mountain that they went ahead and confiscated and used for m. I'm not convinced of it, but whatever. However you want to remember that it's m, that's the main thing. Remember that m is slope. Now, m is the ratio of changes, actually I want an equal sign there, between y and x. So m is a change in y over a change in x. If we go ahead and substitute, we've already seen that a change in y is y2 minus y1 over x2 minus x1. And so now we have a formula. And actually, both of these are formulas. And depending on the situation, you may want to use either one of them. Because sometimes what happens is the change in y and the change in x are easy to see, so you don't have to do the arithmetic. You can just write them down. So now keep in mind too, this formula is based on the fact that we have 2 points, x1, y1, and x2, y2. Right? And again, the subscripts only serve to tell, so you can tell the points apart. That's what it does. It says when they have a different subscript, all that is whoever's right, the author telling you that those are different x values. They aren't the same x value. And so you can tell them apart. Okay, so we have a formula here, and I'm going to rewrite this shortly, but this formula you really do need to memorize. You need to know this formula by heart because it will show up in every level of math that you take from now on. If this is your last math class, well, it's still true. But yeah, this shows up in statistics a lot whenever you're dealing with regression lines and all this kind of stuff. Although the formula is much messier in statistics. It shows up in calculus. In fact, in a lot of ways, it's almost the basis of calculus, looking for the slopes of lines. And so it really is a foundational thing. One of the things that you want to remember is almost everything, when we estimate it, is estimated with a line. And so if you can figure out the slope of that line, that tells you something about your estimation. Okay, so let me go ahead and get this out of here. And so we left off here. M is equal to delta y over delta x. Oops, I wrote that wrong. Which is y2 minus y1 over x2 minus x1. Right? So it's a change in y over a change in x. So the question really is, how do we get a hold of this thing? How do we use this? So, once again, let's suppose you're walking down a dark alley and someone jumps out from behind a dumpster and hands you the point 4, 6, and another point 3, -2, and asks you for the slope. Right? It's either that or empty out your wallet and give them all your money. Right? So this might save you a couple bucks if you can work this out. So here's how I like to do these. Whenever I'm given 2 points, I like to label the parts first. And I'm going to actually work this out using both formulas. I'm going to use this one first because it's probably the more common one to use. But this has its advantages too if you understand how to use it. So I'm going to use this formula to start out with. And so I like to label things. So this would be x1, this would be y1, this one would be x2, and this one would be y2. I advise, especially when you're first starting this out, label the parts. It makes it a lot easier to not put the wrong number in the wrong place. Then, another little tip about studying, if you want to memorize a formula, write it down every time you use it, whether you need to write it down or not. By the time you get to the end of the assignment, you remember it, which is very, very handy. Okay, so let's start plugging these things in here. So y2 is -2. So we'll plug that in. Minus y1, which is 4, over x2, which is 3, and x1, which is 4. Right? So let's see what we get here. So -2 minus 4 is -6. -3 minus 4. Wait, did I do that right? Oh my goodness. I actually put, you know what? After telling you guys to pay attention, I didn't. Let's try this again. I was just trying to show you what not to do. That's what I was doing. I'm glad if any of you caught it. Okay, so let's try this one more time. So it's -2 minus 6. Sorry, I jumped over to the 4. -2 minus 6, there we go, and 3 minus 4. So -2 minus 6 is -8. 3 minus 4 is -1. And so in this case, my slope, -8 divided by -1 is just 8. So I have a slope of 8. Now, one of the things that we do need to pay attention, now we're not, at this point, we're just finding the slope. We're not using it for anything yet. But one of the things that happens when you have whole number slopes is you want to remember that even though it's written as a whole number, it is over 1. So when you need to dice out that change in y and change in x, you can actually still write it as a fraction so you can see the two of them. Although in the answer, you only need to write this if it's asking for the slope. Okay, but when we use it, we will need the over 1. Okay, so that was that example turned a little bit messy, but we still got through it. So it's just a matter of labeling your parts correctly, which we did do that part, and then plugging them in correctly, which I brilliantly demonstrated by not doing. Okay, so here's what I want you to do. We still got this guy up here. I'm going to give you 2 more points, and I want you, I want you to go ahead and find the slope between these 2 points. So the first point is -2, -8. The second point is 6, 1. And so we want to find the slope. So find the slope. I'm just going to shorten the instruction down. Okay, so go ahead and pause it here and give it a shot. Okay, so let's go ahead and take a look now. So we know the formula is m is equal to y2, oh, I forgot to work that other one out the other way, minus y1 over x2 minus x1. And let's label our points here. I probably should have done that first, but I'll label on top. x1, y1, x2, y2. Okay, so let's go ahead and plug in now. So y2 is 1. Now you have to be careful here because we're subtracting a negative on the next part. So y2 minus y1, and y1 is negative 2. So we're subtracting a negative. That turns into a plus. And then we need x2 minus x1. So it's 6. Did I just do that again? I don't know what's wrong with my eyes here today. It's 1 minus negative 8. I said that wrong. So I don't know why I keep doing that. I've been doing this for a lot of years. You'd think I'd have it down by now. Okay, so 6 minus negative 2. So both of them are in the situation where we have to subtract a negative. So remembering that if I'm subtracting a negative, I can just turn them both positive. This gives me 9 over 8. And so we have a fractional slope this time. We get 9/8. In fact, there's a good portion of the time that your slope is going to come out with a fraction, right? Okay, so we have that now. So I do want to do a couple more examples here. So here's what I'm going to do. The next screen, I'm going to put 3 examples down because I want you guys to see some stuff. So here's where, oh yeah, I still got to do that. So find the slope, and I'm going to give you 3 of these. Where we go here? Okay. Negative 24, 3. And it's paired with 6, negative 2. Okay, that's the first one. Now, the second one is, let's see here, we'll go 3, 2, and negative 1, 2. And then the third one will be 4, negative 1, 4, negative 6. Okay, so those are the 3 sets of points that I want you to find the slope between. So go ahead and pause it right here and see what you can compute. And then we'll talk after you push play again. Okay, so let's go ahead and start computing. So again, now I'm going to do these a little bit faster because of the fact that we've already gone through the formula several times. I still encourage you to write the formula down each time. It's also still a good idea to label these guys. All right, so here my slope is, let's see if I can do this one correctly, negative 2 minus 3 over 6 minus negative 24. So let's see here. We're going to turn those into pluses. So I get negative 5 for the numerator, and that is over 31. Now, the other thing is you should check to see if your fraction reduces. I didn't mention that before because nothing reduced. So taking a look at this, negative 5 over 31, there's no common factors here other than 1. So we're not going to be able to change anything. But do know that if this was like negative 5 over 25, you would have had to simplify it down to negative 1/5. Okay, but this is our slope. So you can tell they can look fairly bizarre, right? 31 is not a fairly a usual denominator. Okay, so let's look at the next one here. Let's see, we got x1, y1, x2, y2. Oh, you know what well, I'll do it on this one. Yeah, so if we're going to plug this in here, so m would be 2 minus 2 over negative 1 minus 3. Now, 2 minus 2 is 0. Negative 1 minus 3 is negative 4. But 0 divided by negative 4, I mean, let's just think about it. Remember that the numerator tells you how many things you have. The denominator tells you what you have, or how many pieces things are cut into. So these are, I mean, we don't even have to think about the negative. Just think about them as fourths. I have 0/4, which means I don't have anything, right? So this slope is 0. Now, I just want to point this out too, because I'm going to do both of these the same way right now. If you look at it in terms of a change in y and change in x, because a lot of the time you can just see this, right? Instead of doing the formula, one of the things you do is, let's see, if I'm going to look at my change in y, what I do is I imagine a number line, and I look at the 3 and the -2. And I picture what would have to happen to go from 3 all the way down to -2. I know I have to cover these 3, and then I have to cover 2 more, and I'm going down. So in my mind, I know my change in y is -5, right? Because it's dropping by 5 to go from 3 to -2. Doing the same thing with the number line and looking at -24 and 6. So if you picture yourself sitting at -24, you have to travel all of those 24s up to 0, and then 6 more, and that makes 31. Right? And so if you can picture it in your head when you do that, it actually makes things a lot easier. This one's a good example, right? If I look at my change in y, I move from 2 to 2. It doesn't change. So that means my change in y is 0. Over here, my change in x changes from 3 to -1. Well, to do that, you have to go down 4. So that means my change in x is -4. And notice it's the same numbers I just found. And that still gives us a 0 slope. Now, I want to point something else out about a 0 slope. Remember, slope is a measure of steepness. So if you have a 0 slope, you're saying there is no steepness, or in other words, the line is flat, right? It's a horizontal line. So if I look at that as a graph, I'm going to do a little graph here. Let's look at these 2 points. 3, 2. So 3 and then at 2, we'll say it's right there. And then -1, 2, so that would be down here. And if I look at them, I have a horizontal line. And here's what's even better, is you have the equation of that line too. Anything we saw in the last lecture, anything that's horizontal like this has an equation of y equals some number. Well, let's look at that number. In both cases, the y is equal to -2. So you can, if you find out the slope is 0, you can actually jump straight to the equation. It's y equals 2. Now, we're not quite getting this, with all the graphing and stuff, but I think it's an important connection to remember when we do get to the graphing, because it will save you a tremendous amount of time. If you find out your slope is 0, your equation just got a lot simpler. Okay, so now let's look at the third one here. I feel like I'm running out of room. Okay, so again, x1, y1, x2, y2. And let's see what we got here. So the change in y, so I'll get -6 minus -1. And then 4 minus 4 is my change in x. And let's see, that's going to turn positive. So that means my change in y is -5. And my change in x is 0. That's interesting. How do you take something, no matter what it is, and divide it into 0 pieces? I mean, that's really what this is saying. Let's take something and divide it up so that each piece has a size of 0. That's actually, that's pretty much impossible. So here's the deal. Whenever you have a 0 in the denominator, right, you can't divide by 0. So what this quantity is then is an undefined quantity, right? So this slope is undefined. So an undefined slope is kind of interesting, and I'm just going to make this connection here real quick like I did with the other one. it's kind of like saying it's an infinite slope. It's not exactly the same as that, but it really kind of is. If you think about the steepest possible line you can draw, it's a vertical line. And if we look at these, the x values in both of these are 4. So I actually have a value, let's say the that 4 is over here. I have one at -1 and at -6, and you can see it's a vertical line. And so it's kind of like having an infinite steepness, right? It's as steep as you can get. There is no steeper than this. But that particular number, when you write it down, when you work out the math, comes out to an undefined slope. Okay, so if you get an undefined slope, that means it's a vertical line. It goes straight up and down, right? It's as steep as possible, and it cannot get any steeper. And what's more is in the last lecture, we saw what happened with the equations of vertical lines. Excuse me, it's always in a form of x equals something. So the equation of this line, if we look up here, both of the x coordinates are 4, which means that the line that these 2 points are part of is the line x equals 4. Right? So again, that's getting a little bit ahead of ourselves as far as finding the equations, but it is something that we do need to talk about, and we will be talking about very shortly. Okay. Oops, that's the wrong button. There we go. Now, we've talked about slopes, and I want to bring something up here. Oop, that is not the thing I wanted to click. Let's try this one. Okay. Let's go ahead and put a grid up, and let's graph a line. Let's graph a line that we actually, there we go. We actually know the equation for. So let's say that this line is 2/3. Do I want 2/3? Yeah, 2/3 will work. 2/3 times, I guess I have to, times x minus 2. Okay, so we have 2/3 times x minus 2. Let's graph that guy. Okay, so that's that line. And you'll notice something. I just want to mark some points I see on the line. So I have this point, -2. And I do want to point this out too, is you'll notice that point -2, that's our y-intercept. We talked about y-intercepts before. The y-intercept's where it crosses the y-axis. You notice that that point is something I could have gotten from this -2 here. If I put 0 in for x, I would have gotten this -2. Right? Now, what I want to do is just mark some more points that it looks like we have what's called lattice points directly on the line, right? So I have a few of these, and you notice how equally spaced they are. If I go up 2 and to the right 3 on each one of these, I will get to the next point. And I can do it backwards too. If I go down 2 and to the left 3, I get points on this line. So here's what I want to do. I want to see if I can. Let's do. I'm going to reshape this a little bit so we can see it easier. I know this is riveting viewing, isn't it? Okay. Do that, and then we'll do this. There. This way I can write and we can see the graph. All right. So here's what we want to do. What I'm going to do is basically pick points and find the slope between them. So I'm going to start, let's see if I can do this. I'm going to start by finding the slope between these 2 points here. Okay, so these are the points. Let's see here. Oops, I didn't mean to do that. That's okay. That would be the point 0, negative 2, and the point 3, 0. Okay, and I'm just going to rewrite this over here so we can see it. The full equation of the line is y is equal to 2/3 x minus 2, just so we're aware of it. If I find the slope here, and this one has small enough numbers, I'm going to use the change in y over the change in x, so we don't have to compute. So the change in y, we go from negative 2 up to 0, so that's an increase of 2, so that's positive 2. And the change in x goes from 0 to 3, so that's an increase of 3, that's positive 3. Well, that's interesting. Okay, so we have a slope of 2/3. Now, let's pick two other points. Let's say I pick this point and this point. So let's see here. That would be, that point is the point 6, 2. And this other point down here was the point negative 3, negative 4. So they're completely separate points. Both points are different, but they are points on the same line. That's the only thing these points have in common, is that they are points on the same line. Okay, so again, change in y. So x goes from 2 down to, or excuse me, y goes from 2 down to negative 4. So that's a decrease of 6. So that means my change in y is negative 6. That's supposed to be a negative. Now my change in x. X changes from 6 down to negative 3. So it has to drop 9. So that's negative 9. Now that doesn't look like much right now, but let's go ahead and simplify this. I know a negative divided by a negative makes things positive. And if I divide both of these by 3 to reduce it, I end up with 2/3 again. So I have the same slope one more time. And it turns out that no matter what you do, you end up with the same slope. And it's always this number, right? You notice that is the same number. Oops. That's the same number we started with, or that's the same number we keep finding. We found 2/3 in the first time, 2/3 the second time. And it's one of the ways that lines are defined, that straightness is defined, is that a curve, and now curve is a very general term in math. Curves don't have to be curved. It's just any connection between points, basically. But a curve is a straight curve, is a line, if any 2 points you pick on that curve have the same slope between them, right? So it keeps the same steepness no matter what you do. Okay, so that was kind of fun, but I want to summarize something here. So if we are in slope-intercept form, which we talked about last time, slope-intercept form is the one that looks like this. And I really do include the function definition also. It's not technically the slope-intercept form. It's the function, it's function notation, but it really behaves the same. You can see the whole right-hand side is identical. In any case, for both of these, m is the slope, right? It was no accident that that's the same symbol that we were using for slope. So this is only true in the slope-intercept form. So you can get the slope from this. It's actually quite nice. Now, from the standard form, ax plus by equals c, you don't get to read the slope off of this one so easy. So I'm going to do a little bit of work here, and what I'm going to do is actually come up with a formula to get the slope out of this form also without having to do computation. I know I said formula, and then I said you won't have to compute, but it really isn't much computing. So this would be easier if I could get it into the other form, right? If I get it into this form, then whatever's next to x should be the slope. So that's what I'm going to do. I'm going to take ax plus by equals c, and I want to get y by itself. So I'm going to subtract ax from both sides. So that cancels, and I end up with by is equal to negative ax plus c. And you notice too, I'm reordering these things so that they're in the same order. Now, the only thing left to do is divide by this b. Right? So we'll divide everyone by b. And what I end up with is y is equal to negative a over b x plus c over b. Okay, that tells us two things. If I compare this, let me get some of this other crap out of the way. Sorry, I'm erasing it. Might have been too soon, but you can rewind. Use that rewind button. Okay, so in any case, I want to compare that to y equals mx plus b. Okay, so first of all, this tells us what m is. This tells us how to find m. So m is equal to negative a over b. Right? And we haven't talked too much about intercepts here, but this number here, if we plug in 0 for x, y is equal to b, which means that this b here tells us that the point 0b is a solution to this line, right? And a solution means that it's a point on the line. So the x-coordinate is 0. That means b is the y-intercept. So the point 0b is the y-intercept. All right. Notice I didn't say b was the y-intercept. There's a lot of fudging on that, but the technicality is that b is the y-coordinate of the y-intercept. It is not the y-intercept, and that's a very technical line. If you say b is the y-intercept, almost everybody knows what you mean, so that's not a huge deal. Okay, so let's see here. So that should pretty much wrap up what I want to talk about as far as slope goes. Right? Things we want to remember is that slope is the steepness of a line. We can have negative slope, right? You can have negative steepness, and it's just a matter of what direction it's steep in, right? So if it goes up to the right, then, if it goes up to the right, then it's a positive slope. If it goes down to the right, that's a negative slope. If it's vertical, it's an undefined slope. And if it's horizontal, it's a zero slope, right? So those are some of the things we found. We also found that in the y equals mx plus b, the slope-intercept form, m is our slope. And we also found that we can compute slope from 2 points by finding the difference in y's, right? How much y changes, and dividing that by how much x changes. And so those are the high points of what we want to hit here. Okay, so let's go ahead. Yeah, I think that pretty much wraps it up. And so until next time, let's go ahead and keep our pencils and wits sharp, shall we?